Today we will be looking at 5.3, which is dealing with determinant solutions of linear systems. So every n by n matrix has a real number called the determinant written, and we use vertical bars. In this case we have the determinant of A, and the determinant of a 2 by 2 matrix. We have A is equal to, and we have some elements here. So then we have the determinant of A, and it's equal to, notice we have our purple highlighter here, and we go in the downward diagonal direction, and then we go in the upward diagonal direction. So we have A11 times A22, and then we go ahead and subtract parentheses A21 times A12. Now, one thing to quickly note is we have matrices, and they have square brackets, and then our determinant has these vertical bars. So let's go ahead and take a look at an example here of finding the determinant of a 2 by 2 matrix. So we have B here, and we want to go ahead and try to find the determinant. So let's get our highlighter out. First we go in the downward direction, so we will have a 5 times a -4, and then minus, we go in the upward direction now, so we have 2 times a -8. So 2 times a -8. So this will get us a -20. And we have a negative times a negative, so plus 16. And that's going to be equal to a -4 here. And this -4 should be our determinant of B. So we should be good to go there. So one thing we can look at now is the fact that the determinants of each 2 by 2 matrix is going to be what's called the minor of the associated 3 by 3 matrix. So we have Mij, and it represents the minor that results when row I and column J are eliminated. So say for example we wanted to find the minor of 1, 1. In this case we went ahead and eliminated the row. So we eliminated this row, and then we eliminated this column, and what are we left with? Well, we're left with A22, A23, A32, and then finally A33. So that would be the minor of 1, 1. Additionally, if we were going to go ahead and try to find the minor of 2, 1, we would go ahead, eliminate this column here, eliminate this row here, and what are we left with? We're left with A12, A13, A32, and then finally A33. So now what we can do is use this to our advantage to finding cofactors of elements. So the cofactor, let's go ahead and let Mij be a minor for element Aij in an n by n matrix. And then we have the cofactor of Aij written capital Aij. And that's going to go ahead and be equal to -1, and then we have our I, which represents our row, and then we have J, which represents our column here, multiplied by the minor of Ij. So we want to go ahead and try to find the cofactor of each of the following elements of a given matrix. So our given matrix here is going to be these elements over here to the left. And just for reference, we have our Aij matrix here, just so we can reference to figure out which row and column we need to eliminate to find our minor. So if we wanted to go ahead and find the cofactor 5, let's go ahead and do so. So 5, notice how in this case we would have an I of 1 and then a j of 1. So let's go ahead and fill that in. I of 1 and then a j of 1. And what do we need to do? Well, we need to go ahead and try to find the minor of this one. So we can go ahead and eliminate this row right here, and then we can eliminate this column. So what are our remaining elements? Well, we will have a 2, a -9, a 1, and then finally a 3. So we want to go ahead and try to find the determinant now. So we start with the downward direction. So we will have a 2 times a 3 minus, and then let's go in the upward direction. So our upward direction here, we will have a 1 times a -9. So 1 times -9. And we can now go ahead and find our numbers here. So that will get us a 6. And then plus, because we have a negative times a negative, so plus in this case a 9. So that gives us a positive 15, and we can now plug that into our formula. So again, our formula, we have -1 raised to the I plus j, and then multiply that by what we just found, which was that determinant there, or the minor of ij. So this will give us a -1 to the I plus j, which our I was 1, plus our j, which is also 1, multiplied by our 15 here. So -1 squared is just going to be +1. So in this case, we will get a 15. Okay, let's go ahead and look at b here. We want to go ahead and try to find it of 3 now. So we can go ahead and eliminate this column here and eliminate this row here and write our remaining elements. So we have a 5, a -1, a 0, and then a 2. What is our I and our j here in this case? Well, 3 would have an I of 3 and then a j of 3. Remember, I is equal to our row and then j is equal to our column. So 3, 3. And we can go ahead and perform the necessary operations. So again, we're going to start with the downward direction. So this will be a 5 times a 2 minus, and then in this case, go in the upward direction. So in the upward direction, that's 0 times the -1. So 0 times -1. And that's just going to be 0. So in other words, we will have a 5 times 2, or a 10. So continuing to plug this into our formula, we will have -1 to the 3 plus 3, because this is our 3 is going to be our I, and then our other 3 is going to be our j, which gets us -1 to the 6th power, which is just going to be +1 times, and again we multiply that by our minor here, which was 10. So 1 times 10 is going to get me a +10. And we should be good to go. Okay, so let's go ahead and look at finding the determinant of a 3 by 3 matrix. So say we have a matrix A is equal to, and we know that this is a matrix because we have these square braces here. Then we have the determinant, and what we're going to do is go in the downward direction. So downward direction first, and then we go in the upward direction. So if you can see, our first row is going to be this green highlighter here. So we have A11, A22 times A33, and those are all multiplied. Then we have our other downward directions. So we have in blue highlighter A12, A23, and then A31. Finally, we have our last downward direction, which is going to be that A13 times A21 and then A32, and that's going to be in the purple highlighter. Now we go in the upward direction. So in this case, we have that A31, A22, and then A13, and that's going to be circled in that orange there. And then finally, we have our upward direction of A32, A23, and then A11, and that's going to be circled in the purple. And then our last upward direction that we need to take care of is going to be our A21, A12, and then finally A33, and that's going to be circled in the blue there. And another thing that I can quickly note here is we use parentheses for our downward direction, subtract it, and then we use parentheses around our upward direction. So let's go ahead and look at an example taking care of the determinant of a 3 by 3 matrix. So first we want to start in the downward direction. So let's go ahead and highlight. We will have the 8 times the 0 times the 2. So let's go ahead and write that out. We will have 8 times the 0 times the 2. And we can go ahead and add, in this case, our other diagonals here. So let's find another diagonal. We might have this -2 and then times the 3, and then finally this opposite corner here, which is the 5. So let's go ahead and write -2 and then a +3, then the 5, and find our last downward direction diagonal. So that will be, in this case, we'll have the 7, -1, and then finally the -4. So that should get us a 7, -1, and then finally the -4. We can go ahead and close those parentheses off here and then go ahead and subtract our upward direction diagonals. So let's go ahead and highlight those as well. So our upward direction diagonals in this case, we will have a 5, a 0, and then a -4 for our first one. So 5, 0, and then -4. And then we can go ahead and add our other diagonal in the upward direction, which will be a -1, 3, and then opposite corner, which is going to be this 8 here. So that will give us plus -1, +3, and then +8, and then we can go ahead and add our last upward diagonal. So our last upward diagonal should give us the 7, -2, and then finally opposite corner, which is going to be that +2. So 7, and then our -2 here, and then a +2. So if we go ahead and do the operations that we need to, this top row will simplify to 0, -30, +28, and then minus, we will have 0 plus a -24 minus a 28, and that should get us a value of a 50. So again, let's go ahead and reiterate here. So the 8 times the 0 times the 2 will get us this 0. The -2 times the 3 times the 5 gets us this -30. The 7 times the -1 times the -4 should get us this +28 here. The 5 times the 0 times the -4 it gets us this 0. The -1 times the 3 times the 8 should get us a -24. And then finally, the 7 times the -2 times the 2 should get us a value of a -28. So again, we use parentheses here and take our first number and subtract our second number, and we should get a value of a 50. Next, we can look at Cramer's rule for 2 equations and 2 variables. So say, for example, we are given this system. Then our system has a unique solution of, and we can find the value of x by taking the determinant of x and dividing it by the determinant. And finally, we can find our value of y by taking the determinant of y and dividing it by the determinant. So if we look here, our determinant is going to be equal to, and we have our coefficients of x and y. So we have a1 and a2, a1, a2, and then finally we have b1 and b2, and then finally b1 and b2. So since we're just solving for the determinant of x, we can go ahead and replace, normally we'd have x with our constants, and then we go ahead and keep, in this case, our b1, b2, which is our coefficients of y. And additionally, notice when we're solving for our determinant of y, we go ahead and keep our x's, but we replace our y's, in this case, with c1, c2. So let's go ahead and look at an example of applying Cramer's rule to a 2x2 system. So applying Cramer's rule to a 2x2 system, we are given the following system. 4x plus 3y is equal to 2, and x minus 2y is equal to 5. Again, we know x is equal to the determinant of x divided by the determinant, and then finally y is equal to the determinant of y divided by the determinant. So again, let's go ahead and try to find the determinant first, and then we can move on to x and y. So we will have the determinant equal to, and then we'll use our vertical bars here, and we want to go ahead and keep our coefficients of x and y. So in other words, we'll have a 4 and a 1, and then finally we will have a 3 and a -2 here. And we can go ahead and figure out what this is going to give us. So moving in the downward direction first, we will have a 4 times a -2. So 4 times a -2. And then go ahead and subtract 1 times 3. And that should get you a value of a -11 here. Okay? And additionally, we can go ahead and find our determinant of x. and again use these vertical bars. So what will this give us? Well, since we're solving for the determinant of x, let's go ahead and replace our x column with our constants here. So we're going to go ahead and have a 2 and a 5, and then we're going to have a 3 and then a -2 here. So again, we want to go ahead and move in the downward direction first. So that will give us a 2 times a -2, and then minus, in this case we have a 5 and a 3 moving in the other direction, which is going to be our upward direction here. So that should give us a -4, -4 minus a 15, so that's going to be equal to a -19. Our last one we want to figure out is our determinant of y. So again, we use these vertical bars here. So since we're solving for the determinant of y, let's go ahead and replace our y column with our constants. So again, our constants 2 and 5, and we go ahead and keep our coefficients of x, which is going to be that 4 and the 1. So again, we move in the downward direction first. So this will be a 4 times a 5 minus, let's go ahead and move in the upward direction. So that will give us a 1 times a 2 here. So minus 1 times 2. And let's figure out what values that will give us. So that will give us a 20 minus a 2, which is going to be equal to a positive 18. So we know our determinant is equal to -11. We know our determinant of x is equal to -19. And then finally, our determinant of y is equal to 18. So we can go ahead and figure out what our x and our y values are based off of this information here. So again, let's go ahead and set that up. Our x value is going to be equal to our determinant of x divided by the determinant. So in other words, we're going to go ahead and have a -19 here divided by this -11. So what should that get us? Well, that'll get us a 19 divided by 11. Next, we can find our y. So our y is going to be equal to the determinant of y divided by the determinant. So our determinant of y we found was 18. And then our determinant we found was this -11. So divide by -11, and that is going to be equal to -18 divided by 11. So now we have our x and our y values. We can go ahead and put that into a solution set here. So what's our x value? Well, we found it was 19/11. And our y value we found was -18/11. And we should be good to go. Cramer's rule does not only apply to a 2x2 matrix, but it can also apply to a 3x3 matrix. So in this case, we have our general form of Cramer's rule. So we have an n×n system, and we have linear equations of our form, and we'll have a1 x1 plus a2 x2 plus a3 x3, and then we go on to the general form. So our unique solution, we can have x1 equal to the determinant of x1 divided by the determinant. In our example, we'll have that be the x value. And then we can have x2 equal to the determinant of x2 divided by the determinant. Again, for our example, we'll have that value be y. And then finally, for our example, we'll let that x3 be a z. So then we can have the determinant of x3 or the determinant of z divided by the determinant. So let's go ahead and look at this example of applying Cramer's rule. So we will have a lot of calculations to do here, so let's go ahead and systematically go through this. So the first thing we want to go ahead and do is find our determinant. So in this case, d is going to be equal to, what are our coefficients? Well, we're going to go ahead and keep them for our variables. So a 2, a 4, a 1, a -4, a 6, and then a 1, and then finally a 1, -1, and then a 2. So again, we want to move in the downward direction and then the upward direction. So let's go ahead and find our diagonals here. Our first one is going to be this 2 times the 6 and then multiplied by the 2. And then we can go ahead and add. Let's find another diagonal here. So another diagonal in the downward direction might be this -4, -1, and then opposite corner of a 1. So -4, -1, opposite corner of a 1. And then we can go ahead and add our last downward direction diagonal, which is going to be this 4, 1, and then opposite corner, which is going to be a 1 here. So in this case, 4, 1, opposite corner, 1. And we can go ahead and close off those parentheses and subtract. So our second one, we want to go ahead and take care of the upward direction. So let's go ahead and figure out what those are going to be. Our first one is going to be this 1, 6, and then this 1 here. So 1, 6, and then finally the 1. Plus, let's find another one. Another one might be this 1, -1, and then opposite corner of a 2. So 1, -1, opposite corner 2, and then add our last one. So our last one here is going to be this 4, -4, and then opposite corner of a 2. So plus 4, -4, and then finally opposite corner of a 2. And we can go ahead and close off those parentheses here. So let's go ahead and figure out the value of our determinant. The value of our determinant is actually going to be equal to a positive 60. So let's go ahead and box this so we can find it easily for later. So now that we have found the determinant, let's go ahead and find our determinant of x here. So our determinant of x, let's figure out what values we need to put in here. So since we are solving for x, let's go ahead and replace our constants with our x column. So the first thing you'd want to go ahead and do is actually go ahead and add these constants over to your right hand side. So if we go ahead and do so, what is that going to give us? Well, we have a -19 here, so that becomes a positive 19, -15, and then finally a positive 11, and we can go ahead and erase them from our left hand side here. So now that we have our constants, let's go ahead and put that in the column that we need it. So that will give us what? A 19, -15, and a positive 11. And then what else do we have? Well, we have our y and our z. So in other words, we have our -4, 6, and then 1. So -4, -4, 6, and then a 1. And our last is going to be our z, which is a 1, -1, and then a 2. So we can go ahead and have a 1, then a -1, and then finally a positive 2 here. All right, so let's go ahead and move down a little bit and figure out what our diagonals are going to be for this one. So again, we want to move in the downward direction first. So one of our diagonals here could be this 19. So 19, and then times the 6, and then finally times that 2. And then we're going to go ahead and add. Let's find another diagonal here. So this could also be our -4, -1, and then opposite corner, positive 11. So let's go ahead and add -4, -1, and then opposite corner, which is going to be that positive 11 here. And then finally we can go ahead and add our last diagonal. So our last diagonal is going to be this -15, 1, and then opposite corner of a 1. So -15, 1, and then opposite corner of a 1. And then we can go ahead and subtract. Let's go in our upward direction now. So our upward direction, let's figure out what our diagonals are. So we'll have an 11, 6, and then finally a 1. So we can have an 11, 6, and then a positive 1. Plus, let's find other diagonals here. So we could have a 1, a -1, opposite corner, positive 19. So 1, -1, opposite corner of a 19, and then our last diagonal here. Our last diagonal is going to go ahead and be this negative 15, negative 4, and then opposite corner of a positive 2. So we have a negative 15, negative 4, opposite corner, positive 2. So if we do the calculations and plug it into our calculator, what we should get is a value of a positive 90 here. So let's go ahead and box that so we can find it easy for later. We still have two more determinants that we need to find. We need to find the determinant of y, and we need to find the determinant of z. So let's go ahead and find the determinant of y here. So the determinant of y is going to be equal to, let's go ahead and find out what numbers we need here. So again, we're finding the determinant of y, so we can go ahead and replace our y column with our constants. So let's go ahead and figure out what numbers we need here. So let's go ahead and keep our coefficients of x. So that's going to be a 2, 4, and 1. So let's write a 2, 4, 1. And then we said we're going to replace our y column, because we're solving for a determinant of y, with our constants. So that would be a 19, negative 15, and then an 11. So we will now write a 19, a negative 15, and then a positive 11, and figure out what our last column here is going to be. So our last column is going to be our coefficients of z, so a 1, a negative 1, and then finally a positive 2. So we are left with a 1, negative 1, and then a positive 2. And we can go ahead and figure out what our diagonals are going to be. So again, we want to go ahead and move in the downward direction first. So we are left with a 2 times a negative 15, and then multiplied by a 2 here, plus, let's go ahead and find another diagonal. So another diagonal, 19, negative 1, opposite corner of a 1. So 19, negative 1, opposite corner of a 1, and add our last diagonal here. Our last diagonal is going to go ahead and be this 4, 11, opposite corner of a 1. So 4, 11, opposite corner of a 1, close off your parentheses, and then go ahead and figure out what your diagonals are in the upward direction. So what will this give us? Well, we might have a 1, negative 15, and then a 1. So 1, negative 15, and then a positive 1, plus another diagonal we could have is going to be this 11, negative 1, opposite corner of a 2. So 11, negative 1, opposite corner of a 2, plus, let's figure out what our last diagonal is here. And that's going to be this 4, 19, and then opposite corner of a positive 2. So 4, 19, opposite corner of a positive 2. All right, and if we go ahead and plug this into our calculator and do the calculations, we should get a value of a negative 150. And again, we'll go ahead and box this so we can find it easy for later. So our last one we want to go ahead and figure out is going to be that determinant of z. Let's go ahead and figure out the determinant of z and our numbers that we want inside of here. So again, since we're solving for the determinant of z, we can go ahead and replace the z column with our constants. So let's go ahead and keep that in mind. So our first column is going to be our coefficients of x, which again is going to be this 2, 4, and a 1. So we can go ahead and write a 2, 4, 1. And then our coefficients of our y are going to go ahead and be this negative 4, 6, and then finally a 1 here. So we can go ahead and write a negative 4, 6, and then a 1. And then what do we have left? Well, it's going to be our z column, which we said we can replace with our constant since we're solving for the determinant of z. So that's going to be the positive 19, negative 15, and then finally a positive 11. So again, let's go ahead and figure out what our diagonals are going to be, moving in the downward direction first. So we might have a 2, 6, and then an 11. So 2 times the 6 and then times the 11, plus another diagonal that we might have, this -4, -15, opposite corner of A1. So -4, -15, opposite corner of A1, plus our last diagonal in the downward direction here is going to go ahead and be this 4, 1, opposite corner of a positive 19. So 4, 1, opposite corner of a positive 19 here. And go ahead and close your parentheses and then subtract our upward diagonals here. So our upward diagonals, we can go ahead and find our first one. That's going to be this 1, 6, and then 19. So we can have a 1, a 6, and then a positive 19. Plus, let's find our other ones. So we could have this 1, -15, and then opposite corner of A2. So 1, -15, opposite corner of A2, and then add our last one here, which is going to go ahead and be this 4, -4, and then opposite corner of a positive 11. Okay, and when we do the calculations and plug this into our calculator, what we should get is a value of, in this case, we should get a positive 360. So let's go ahead and box that so we have it for later. So we can go ahead and write out the information that we know. So we already know that our determinant of z was equal to 360. We know that the determinant of y was equal to what we just found previously, -150. We know that the determinant of x is equal to, let's go ahead and find that up here. That was equal to a positive 90, so positive 90. And then our determinant was equal to, let's go ahead and find that back up here. That was equal to a positive 60. So we can go ahead and write that one as well. So equal to a positive 60. And we can go ahead and figure out what our x, y, and finally our z are. So our x is going to be equal to the determinant of x divided by the determinant. So in other words, this is going to be equal to a 90 divided by a 60, which is also going to be equal to 3 divided by 2. So 3 divided by 2, we can go ahead and box that, and we can figure out what our y value is going to be, and then finally our z value. So our y value is going to be equal to our determinant of y divided by the determinant. So that is going to be equal to a -150 divided by a 60. And that will actually reduce to a -5 divided by 2. So our last value that we can find is going to be our z. So our z is going to be equal to our determinant of z divided by the determinant. So that is going to be our 360 divided by our 60, which is also equal to a 6. So we have 3 values here, and we can go ahead and put this into our solution set, starting with x, then y, then z. So what was our x? Well, our x was 3/2. What was our y? Our y was -5/2. And then finally, what was our z? Our z was a 6. So this is going to go ahead and be our solution set to this equation.